Hi everybody, we're going to be talking about functions and whether or not they have a relationship. So the first thing is we need to describe what a function is. A function is a special relationship between values. So each x value, which we would say that's what we're putting in, so that's our input, has exactly one y value, or what we would call our output. So this would be an example of a function. If we have 0, 6, 5, 2, 7, 9, and 11, -1. And the reason why this is a function is because all of our x values are different. None of them repeat. However, over here, these values would not be a function. And the reason why these would not be a function is because here there are two -1s, and they both have a different y value. So these are not a function. So let's look at the first 4 questions. Let's determine whether or not this is a function or not. So just remember, when we write ordered pairs, it always goes x, y. So let's see if any of our x's repeat. So we have 5, 3, 2, 0, -1. Did any of our x's repeat? They're all different. That means that this is a function. Let's look at number 2. Do any of our x values repeat? Well, here our x's repeat. Now, let's just check to see, are the y's different? So this one is a -4, and that one is a +4. So because we have the same x value, but a different y value for each, this one is not a function. Let's check number 3. Let's check our x values. I see that we have 2 -3s, and let's check the y's. So we have a -1 and a 2. Those are different y values for the same x, so this is not a function. And then let's check out number 4. 1, 2, 3, 4, 5. Those are all different x values. So yes, this is a function. Okay, let's look at our tables to determine if these values are a function or not. So just remember, our x's cannot repeat. Each x must have the same y value. So looking at our x values here, I have two 3's as my x value. Now if I look directly over, they have different y values. So for the first one, the 3 pairs with the y, and the second one, the 3 pairs with the 3. Because they have a different y value, this is not a function. Let's look at number 6. Looking at my x values, do any of my x's repeat? Let's check. -4, -2, 1, 2, 5. They're all different. So yes, this is a function. Let's look at number 7. Look at my x values. -5, -3, 0, 1, 2. They're all different. Yes, this is a function. Let's look at number 8. 1, 4, -7, 4, and -1. We see 4 twice. And looking, positive 4 goes with -3, and positive 4 goes with 2. So because there is 2 different outputs, this is not a function. All right, number 9. Let's look at our x values. We have -8, -4, 0, 4, and 8. They are all different. So that is a function. And number 10. Let's check out our x's. So 1, 2, 3, 4, 5. They're all different. So yes, this is a function. Now let's look at a mapping to determine whether these relations are a function. So what is easy to see is that we have from each x value, there are lines coming from each x value to go to a y. So because there's only one line leaving the x value, that means that there is only one output. So for number 11, this is a function. If I look at 12, we have a line from -4 to 4, but we have 2 lines coming from -1. So because there's 2 y values that are corresponding with the -1, this is not a function. And then let's look at 13. So we have -1 that goes with 2. We have 0 that goes with 1, 1 that goes with 2, and 2 that goes with 5. There's only one line leaving the x values, so this is a function. Okay, we just looked at a set of points, a table, and then also mapping to figure out if the points are a function or not. And now we can look at a graph to determine whether or not it's a function by using the vertical line test. So the vertical line test is if a vertical line intersects a graph more than once, then it is not a function. So just a reminder, a vertical line goes straight up and down. So if I'm going to look at this x and y axis, and my graph looks something like this, this is a function, because if I drew in vertical lines that went straight up and down, it only touches my red line at one point. Now, if I have a graph that looks like this, if I draw my vertical line here, this vertical line will touch here and here at the same time. Thus, this is not a function. Okay, so let's look at a graph, and we are going to use the vertical line test to determine whether or not this relation is a function or not. So my first vertical line will go here. And because these 2 points, here and here, are both on this vertical line, this is not a function. All right, let's look at number 15. Vertical line, so that's good so far. Vertical line, that's good so far. Vertical line, that's good so far. Vertical, good. Good, so on all of these vertical lines, there's only 1 point, so this is a function. All right, let's look at number 16. All right, so this is exactly like my example up top. All of these points will pass the vertical line test because the line only touches 1 time. So this is a vertical. This is a function. It does pass the vertical line test. Number 17, vertical line. Here I have a point here and here. Those are 2 points on 1 vertical line, and this is not a function. Okay, and now let's look at number 18, and let's figure out if this is a function by using the vertical line test. So I'm going to just draw a vertical line right here, and I instantly see that there are 2 points that are on my line and on my circle. So because there's 2 points, this is not a function. All right, number 19, vertical line test. If I draw a vertical line straight up and down, anywhere, there's only 1 point that touches through the red vertical line. Therefore, yes, this is a function. And then number 20. So number 20, it might look a little bit complicated, but if I just draw a vertical line test, do you see how all of these points are on this red vertical line? Any vertical line is not a function. And then looking at number 21, so let's draw our vertical lines to see if at any point there are 2 points that go through our vertical lines at any given point, and I do not see any, so this is a function.